Hello students, as we were doing exercise 15.1 in chapter probability, and I have sent you video for that and some notes for that. So we are moving ahead after that. Children, you have question number 6 in that exercise. Refer to table 14.7 chapter 14. There is a question you have to find in that the probability of marks less than 20% and again marks 60 or above. So let me take you to that table. Here is the table for that, and in this question now you have been given here a teacher wanted to analyze the performance of two sections of students in a mathematics test of 100 marks. So looking at the performances, and the table is arranged here. So now let's come to the point only. What you are given here, you are given marks and the number of students. The marks are starting from 0 to 20, then 20 to 30, 30 to 40, and so on. 70 and above means up to 100 also. Okay, and number of students are also given in the other column. Now our question is to find probability less than 20%. So let's go for the solution here. We have to find probability less than, this is the symbol for less than 20% marks. So that is equal to number of favorable outcomes upon total outcomes. So children, as I have told you, the result of any experiment is called outcome. So how many are favorable outcomes here? Let's see over there, less than 20. So 0 to 20 is nothing but less than 20 only, because after 20 the rest of the marks are given afterward, but 0 to 20 is the only favorable case here. So 0 to 20 means the marks less than 20. So how many students are there? So favorable outcomes are 7. So we can write here in the favorable outcomes 7, and out of how many students were there for that particular exam or test? There were 90 students. It's given there at the last, total are 90. So total outcomes are 90. So 7 out of 90. Children, now I think this is in the lowest term, so we can't further do any cancellation. So this is our answer. If you want to change it into decimal, you can obviously change that. You have done in chapter 1 how to divide them. Point, then 0, again 0, again 0, and it will go on 7, because 8 9 the 72, so it will go on 7. So it's around 630, and it is repeating, so you can write approximately 0.07 is the probability. So this is your answer. So this is the answer for the first part. So we are done with the first part, that is probability of less than 20% marks. Now let's do second part, probability of marks 60 or above. In fact, we can write it in symbol P greater than equal to 60. Children, here see, both the signs combined here, greater than and equal to 60. So let's see the favorable outcomes here. How many are the favorable outcomes? 60 and above. 60 to 70 is also 60 above, and 70 and above is also above that. So we are having two cases here, right from 60 till end. So means 60 to 70 is how many? 15, and 70 and above is 8. So we have two favorable cases here, 15 plus 8 out of 90. So 15 plus 8 is 23 out of 90. So this is our answer for the second part. So I think you are able to understand how can we use the symbols also in the probability, less than symbol, greater than and equal to. That's why you must have seen over there that minimum value of the probability is 0 and maximum for that is 1. So that's why I represented it as 0 is less than equal to P of E is less than equal to 1. So this notation we have used earlier also This is a very important notation. Okay, so I hope you are done with this question. Let's take now the next question. Student, let's have our next question as question number 8, which is referred to question number 2 of exercise 14.22, and in that find empirical probability that an engineer lives number 1 less than 7 km from place of work, number 2 more than or equal to 7 km from the place of work, number 3 within half kilometer from the place of their work. So let's have the table for that, or the data for that. This is our exercise 14.2 and it's stats chapter actually. So here the question is given to you like the distance in kilometer of 40 engineers. So you are given about the data of that 40 engineers from the place of their work to their residence, that how much distance they travel total for their place of work. So this is the distance given to you as 5 kilometer, 3, 10, 20, 25, 11, 13, 7, 12, 31 and so on. You are given in 4 rows over there all the information. Actually what you have to do, you have to find now the probability. So let's do that. Our first part is you have to find the probability of number 1 less than 7 kilometer, less than 7 kilometer. So let's take the favorable cases here. Highlight the cases with pencil. See here, less than 7 we want to see. So this is less than 7, 1. This is also less than 7, and 7 is not less than 7. 7 is equal to 7. So 2 is less than 7. Then further 3 is less than 7. 5 is less than 7. Again 3 is less than 7. 2 is less than 7. 6 is less than 7. And again 6 is less than 7. So I hope all the cases we have circled here, these are the cases which are less than 7. So count them: 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 is the favorable outcome here. So we are writing here number of favorable outcomes are 9 out of the total students, total engineers were 40. So we are going to write 9 out of 40. This is your answer. You can convert it into decimal also if you want, like 40 outside and 9 inside, and then 0.0, go at 40 to the 80, then 10, 100, 40 to the 80 again, 20, and then 5. So this is 0.225. Student, it is not necessary that you have to write the decimal. You can also leave your answer up to here. So the probability of the engineers to travel for a distance of 7 km from their residence is 9 by 40, that is 0.225. Now let's have the second case here. Second case is probability of the engineers who travel more than or equal to 7. It's greater than or equal to 7. So children, see now we have to find this. I'll just guide you one step. Less than 7 is how many? 9 out of 40. So the remaining ones are greater than or equal to 7. So you can directly do that. Now favorable outcomes is 40 minus 9, that is 31. So your favorable outcomes are 31 and total outcomes were 40. So this is the probability for that, 31 out of 40. And again you can convert it into decimal if you want, that is up to you. Okay, and now let's, in order to verify for you, let's do it in the book. See, the circled one I'll not count, I'll count the rest of the numbers, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. So 31 cases are there, means 31 persons are there who travel a distance of greater than or equal to 7 from their place of work. So I think this is verified. So probability is found. Let's go for the third part now. Probability of within half kilometer from their place of work, half, is equal to, let's see the favorable outcomes. See children, if you watch the numbers carefully, not even a single number is in fractions, that means half or decimals. All the numbers are perfect, means these are the natural numbers. No one is in the fraction. So what kind of event is this? This is impossible event, means no half is there. So when this type of case is there, this is impossible event. So you know very well what is to be done for the impossible event. For impossible event, the favorable are 0 and out of 40, and that is 0. So that's all about this question. This was a question again from NCERT book only, question number 8. Let's take now a bit problems of means I'm giving you certain question in which you have to do at least and at most cases. Once again I'm telling you, at least and at most, they are very very important. Hello students, here is our most important question, and might be possible this is not given in your NCERT book also. So that only data I have taken and we are doing it. Children, this is a question in which you are throwing a die 1000 times. Suppose this is the die thrown, this is my dice, and suppose I am throwing it, rolling it, I am getting 3 dots and I am writing its outcome under 3 here. Okay, similarly if I roll it and now here I have got 4, so I'll write the information under 4 only. Again if I roll it, I'm getting 1, I'll write it under 1. So how many times I'm repeating it? 4, I'll write under 4. Again simply I'm getting 3, again I'll write under 3. Then again I'm rolling it, again I'm getting 4. So this type of, in this way the whole experiment is repeated once. Sometime I'm getting 1, or sometime 2, sometime 1, sometime 5, sometime 4, and sometime 6. So all these outcomes I'm getting in throwing of dice, and I'm repeating this experiment how many times? 1000 times I'm doing. So accordingly I've arranged the information in that table. Now our target is to find these cases. Number 1, probability of at least 5. Number 2, probability of at least 3. Probability of at least 4, that is your third part. Then probability of at most 1. Probability of at most 2. Probability of at most 3. How to find the probability for at least and at most cases? This is our important part here. So first part I am doing for you, probability of at least 5. What does it mean, at least 5? At least 5 means minimum 5 you must get, minimum 5 number you must get. So maximum you can get anything, but minimum 5 should definitely come. So in this case I'll underline 5 as well as 6, because minimum 5 they have told, so I will take 5 as well as 6. So what are the favorable outcomes for that? Favorable outcomes are 180 plus 190 out of, the total outcomes were, the rolling of the dice was done 1000 times. So I'll get it as 370 upon 1000. And now children, if you will see, here 0 and 0 can be cancelled and you will get probability as 0.37. So this is the case of at least 5. Minimum 5 should come and more than that can come, but not less than that. Similarly, let's consider the second case now, probability of at least 3. What about that case now? See here, at least 3 mean minimum 3 should come and more than that can come, but not less than. So these two are cancelled in that, so means I can consider 3, 4, 5 and 6. So I will have favorable outcomes here as 160 plus 150 plus 180 plus 190 upon 1000. And now your answer will come as, you can add it, 6 and 5 11 plus 8 19, 19 plus 9 28. So 0 will come and 8 will come, 2 carried over, 3 4 5 6, 680 upon 1000, and this is equal to 0.68. So our second case is also done, at least 3. Now next is at least 4. So I think you must have learned the trick. At least 4 means 4 तो आना ही चाहिए, and after that mean 5 and 6 can also be considered. So our favorable outcomes are 150 plus 180 plus 190. These are the 3 cases for us now. So we can write here favorable outcomes in that. It's 150, then 180 and 190 out of 1000, and that is equal to 0 will come, 9 plus 8 17 plus 5 is 22, 2 1 3 4 5, 520 upon 1000, and if you cut that you will get the probability as 0.52. So these are the 3 cases of at least. So in at least, once again I am telling you, at least means kam se kam. If it is at least 3, then 3 जो भी आ रहा है that can be considered, but 3 से कम नहीं चलेगा, means neither 2 neither 1 will come in that. Okay, and if it is at least 5, then I will consider 5 and 6, 5 and more than that, not less than that. Okay, so this area is eliminated in that for 5 and 6, for 5. Okay, similarly for 4, these observations you are going to add, but this portion is eliminated.